Ladies and gentlemen, please welcome to the stage Bruno Lachag, Senior Executive Vice President, Americas Field Operations, Global Brands, and Indirect Channels.
So, this being said, I want to invite Nyle, but before that I'm going to say a word. I'm going to say a word because I remember one of my first meetings when I was joining Dassault Systèmes was when Boeing decided to go with Katia to do the 777 with the well-known Alan Mulally, chief engineer, and they came in Paris, where we are 200 people, I think, something like this, and there was more people from Boeing than the people in the R&D at Dassault Systèmes. and I remember Bernard, because Bernard took it personally, and he said, okay, we are going to do this airplane. And it cost me the fact that I had to go once a month there in order to be sure that we'll be able to design the part which was necessary to do the virtual airplane. But more important than this, I think, and I was sharing that with Bernard, there was one company who did help us when we started, when Charles has created the company, this partnership with IBM, which made us directly an international company. We have never been a French company. We had more customers outside of France than inside of France. Whatever is in Japan, in US, and big one. And they have been one of the catalysts of what we are today. And the second was Boeing. Because when they came and they said, okay, we are going to do an airplane, we are going to do 100% digital, and we are going to do the digital mock-up of it, and so that we can see things before we freeze and before we release the part. And you have to know that even today in the industry, there is a lot of companies who don't apply what I just said, which is to be simple, but the DMU process is still a lot. So Nyle is part of the person who has been meeting me a long time ago and challenging us. And today, I'm very pleased to have him on stage. And as the director, the one who is driving what is going on in additive manufacturing at Boeing. So Nyle, very welcome. I'm going to give you that.
Okay.
What I want to tell you is that remember those who were here 1 year ago, there was a lot of discussion about additive manufacturing in the science event. And what did happen since then? It's well known. We have been renewing our partnership for a while. And what is going to show you is what did happen since 1 year. Mm-hmm. So welcome, Nyle.
Thank you.
And you have the microphone.
Thank you, Bruno.
Thank you.
Thank you. I'll start with a story for you about my experience with Dassault on the 787 program. So I joined the program in 2003, and I had the opportunity to lead a design team working on the first one-piece composite fuselage. And we had just adopted Dassault Systèmes V5 platform. And if it was not for that tool, these models we had for a complete fuselage section were monstrous. And without Dassault Systèmes tools, I don't think we ever would have been able to design that airplane. So I'd like to start with a quick video that I think aligns very well with the theme of this conference about science in the age of experience. And so could you cue the video?
There is a question as old as time, heard round the world and in every heart. It thrills the imagination and gives wings to possibility. Its footsteps fill history, and its hands hold destiny. It whispers in the dark, and its echo shakes the earth. The question called to those who came before, and they answered with the incredible. It urged them to start small and think infinite, to pursue possibilities and dream no small dream, to see a future filled with hope and unite to build something better. Working together, they connected continents, Building the future of flight, they unlocked the stars. Leading their generation, they inspired ours. To dream high and fly far, to bind together and build the future. To lead our world and find new ones. To honor their legacy and leave our own. Our founders heard the call, and their answer lives on. From ocean waves to the edge of space, through our first century and into the next, their memory remains. Now, it's our turn. The question is calling louder than ever. What will we dream next?
All right. So I know it's after lunch, and it's in a dark room, and I've been in your seat before, so I want to get some interaction going. Let me ask a question. How many of you flew here to Boston? Just maybe take this opportunity to stretch. And how many of you flew on a Boeing airplane? Lots of hands. How many of you weren't paying attention to what airplane you're on? You're just worried about what seat you were going to be sitting in. And that's not uncommon. In fact, if you think about what air travel has become today, we take it for granted. So I love the video that started this with looking forward 100 years. So let's think about going back 100 years. And what if you had to go back in time and we could travel back 100 years and you explain to someone what air travel would be like in 2018? And looking back in 1918, air travel was, I think the Sopwith Camel biplane was the in-airplane. And so what would that be like? You would say, well, in the future, you'll get into this big metal tube, and you'll hurl down a long and wide road up to 150 miles an hour, and then you'll lift off and go 7 miles up in the sky. And you'll accelerate to more than 500 miles an hour, and the outside air temperature will be 50 below zero, and life is impossible. That's what we do. But you'll sit inside in comfort and enjoy a drink and some snacks, and a few hours later, you can touch down on the other end of the country. It's truly remarkable what air travel has become, and we all take it for granted. So think about that as we go forward and what 100 years from now might be like. And so today for Boeing, we are 140,000 employees with products that span the globe in both the commercial and defense sectors and out into space. I'm really excited about our work on the commercial crew capsule, which I hope one day will take, in my lifetime, men to Mars. We support those customers in more than 150 countries around the world. But let's talk about what we're really here for. So in aerospace and in additive manufacturing, I think we're making a transition that is moving from what was prototyping and a lot of medical device industry to aerospace, where it becomes a value proposition. And as we move forward, we're finding that it's generating faster innovation at a more affordable cost. Printing has its challenges, but it is showing us better product affordability and improved performance. And in the aerospace industry, performance is very, very important to us. In aerospace, it really starts with materials. And if you take a look at the top left there, the material systems that we've used today are not all that different, they're just more advanced. Back in that day, someone had to decide what kind of wood they were going to use. Was it had the good strength to weight ratio? Was it light? Was it affordable? What is available? And as we've moved forward, it's translated into metals and into composite materials and an advanced structure for space travel. But really the systems are the same. So when we look at additive manufacturing today, it's really the next leap in technology, but it's very similar to the products we have. We're now just talking about, instead of loggers and miners and metal forgers, now we're talking about spheroidizers and people who will make the powders that will produce the parts that we hope to make in the future. The photo here on the left is our 737 factory of about a decade ago. And you can see it looks very busy. It's got many bottlenecks in it. And as that production system started to advance and try to go faster, we just continued to find more and more challenges. And on the right is a photo of today's factory in Renton. This moving line is one of multiple identical moving lines that are producing 47 airplanes a month today, going to 52 later this year, and 57 airplanes a month next year. That speed and velocity is tremendous for us. We've never gone faster in any production line, and additive manufacturing is one of the keys that we're using to help deliver that production system. On the left, a manufacturing technician on the floor, if she needed some tool to help her build the airplane easier, would go to a tool design engineer, and then that tool design engineer might come up with something new and send it out to one of our suppliers, and maybe 1 or 2 or 3 months later, a tool would show up that would help to build the airplane better. At today's production rates, more than 100 airplanes could go by before one of these parts could show up. So today we are deploying additive manufacturing down to the factory floor. We have engineers, tool designers, and 3D printers located on the shop floor, and it is enabling us to take sketches and turn those into tools and parts that help to build the airplane maybe the next day. And this kind of technology is something that we've applied, and it's really one of the keys that are helping us to move forward. On the left there is galley fitting. It supports the galley on the 787. It's made of titanium, and it's a 3D printed part. It looks very similar to the machine part, but it was made using a 3D printing process called titanium wire feed. And it is the first FAA-approved structural titanium part to be flown on a commercial aircraft. And as of now, we're delivering them on all of our 787s. And this part is made with an additive process where the wire bead of titanium is put down just where it's needed, and it's something we call a buy-to-fly improvement. Traditionally, this part would be made with a block of titanium, which is very difficult to machine and very expensive. And with this process, we're able to put just the right amount of material in the right places, and then significantly reduce the amount of machining that's required in order to produce the part. On the right is a prototype we have. It's called the snubber fitting. I have one in my pocket here, and I think it's maybe visible on the screen. It's a topology optimized design using a generative design software tools, and it is on the 777 today. And we have created this to replace an existing machine part. It also has a very good buy-to-fly improvement. This was built using a titanium powder bed technology, and it is just recently flown on the Eco Demonstrator program at Boeing. It was a partnership between Boeing and Federal Express, and we flew this on a 777 freighter for several months, along with about 30 other new advanced technologies. And this part is one of our first that we're trying to additively produce using titanium powder bed technologies and move that towards production. So Boeing is not new to additive manufacturing. In fact, we have been in the business for roughly 20 or more years, and we started with things like stereolithography. Very first 3D printing, when I first started the company, I remember having these yellow models that were just basically polymers that had been 3D printed, and they were very expensive. And as we've seen over time now, my kids are using their desktop printers in their classrooms. And engineers all over the company, many of our companies are now coming into the workforce with 3D printer experience. But the proliferation of that technology, I think, is still on its infancy. We are really just starting to see how the technology is taking off. But at Boeing, we have been doing this for a while. It's been more than 15 years since we put the first 3D printed part onto one of our aircraft. We have a number of parts flying today, both in commercial and military aircraft. More than 60,000 parts are currently flying. Many of those are polymers. And what we're seeing today is an advancement of new metals technologies, and that, I think, is where a lot of this industry is headed. We also installed the first, we also created the largest solid 3D printed item, and I'll show you a video just here in a moment, together with our partners at Oak Ridge National Labs. So maybe we'll go to that, and let's see if we can get this to play. So it doesn't have any sound, but this is a large area polymer printer at Oak Ridge National Labs that Boeing partnered with to fabricate a tool for development of the 777X program. And at one point, this was the world record holder as the largest 3D printed item. It was over 1,600 pounds, and I'm told it took more than 30 hours to print. And it's a little long, but you can kind of see 30 hours sped up over a few seconds. So maybe we'll watch this just for a moment. You might be able to pick out what kind of part it was, what kind of tool it was for by the shape of what's happening in the middle of that printer there. All right, let's move on. So one of the things that additive is giving to us is greater affordability. And as you saw, low-cost tooling and production is one of those key areas that we're finding great value in. In fact, some of the tools we produced have saved as much as 80% over their original traditionally manufactured costs. And the speed at which we're able to do this is significantly faster. Those two gentlemen there on the left are holding up just some very small printed tools that assist the assembly of the 737. And like I mentioned earlier, these innovation cells that are on our factory floors, these guys came up, asked for help to assemble the wing because we were finding that downstream in the production system, if they weren't accurately aligned, then we would have quality issues and we would have to be reworking the airplanes before delivery. And so these guys came up with a very simple solution of just these small plastic parts that can help to align the bolts assembling the wing. And they were able to get these printed. And now every airplane going down the line is coming out perfectly. And on the right is a flexible 3D printed honeycomb structure. If you're familiar with some honeycomb core that's used in a lot of interior components on the airplane, it's a very stiff material and it's not very flexible. It creates a lot of challenges with the production, and so new 3D printed technology is being applied to have flexible tooling or flexible cores that will allow us to build the airplane easier. And they also are reducing the weight of the products through various technologies. We're also finding that there is faster speed to market as we move forward. Being able to produce the tools like in that video, we are able to take what used to be a flow of 3 to 4 months to acquire a tool, and nowhere near that large. But to be able to acquire large tools took many months to produce. And now, as you heard, that part was printed in just 30 hours. And so we can significantly reduce the time to market. It allows us to look at more customization and be able to take things like interior components on the airplane and customize those for individual customers. This part here is off of one of our satellites, and it may have already been launched into space, but it is a radar array bracket, and it looks pretty normal, but it's been 3D printed using a titanium process, and it allowed the engineers to combine the functionality of multiple parts together and package them in a very tightly controlled environment that would allow the satellite to deploy some of its antennas when it reached orbit. And we now have hundreds of satellite parts that we are designing and developing to put up into space. And that functionality is significantly helping us with the design envelope of being able to package satellites better and reduce the payload weight. Additive does have many challenges. Some of those are part size limitations. The printers in metal parts today have not a very large build area. The materials are very expensive as well, so before you were able to print, you need to make sure you've got the right design. And the role of our regulators is key in the aerospace industry, and how we partner with our regulatory agencies is going to be really important going forward as we work to look at implementation of these new technologies and keep them aligned with us and partnered together so that we can certify the parts and we can get them approved and onto the airplanes, because the most important thing to us is safety. And nothing is more important than safety. If you think of that story I told at the beginning of trying to explain flying in a 737, you know, flying, it's safer than driving to work. It would be safer than 100 years ago than riding on a horse. So we don't want to do anything that would mess that up. We also are challenged by talent and being able to attract and maintain and train those engineers and retain them in the environment that we have, where additive manufacturing seems to be taking off everywhere. And so we are partnered with some of the universities and other industries to help us train our engineers. In fact, Dassault Systems has been very helpful in training our engineers with the 3D Experience platform. And finally, there are specification documents that are very important for production of parts. And that's an area where it's a very big challenge today to have process specifications, material specifications that are consistent when we have many new industry entrants into the additive space. They come with new machines, new technologies, new material systems, and none of these are consistent across the board. And so managing that and being able to control them in an environment that would allow us to produce parts that we can put on the airplane are another challenge for us. Now, fortunate for us with our partnership with Dassault Systems, last year after an exhaustive evaluation, Boeing chose to adopt the 3D Experience platform as part of our digital transformation. And my team, most recently, has had the opportunity to use the additive manufacturing platform. And this is a little busy chart, but I'll try to walk our way around it. And you saw a little bit of this in Bruno's presentation. So we'll start at number 1, where we are able to use an analytics tool to look at the geometry of the parts on our airplane, the millions and millions of parts on our aircraft, and start to evaluate them based on geometric features for candidates for additive manufacturing. And then as we create those models, we're able to really functionally generate the additive space, the design. We're able to, just like that part I showed you, this number, it uses a topology optimizer, and it really looks much more different than any traditionally machined part, and it cannot be made by a normal machine process. And this type of design, using a topology optimization, has, in this case of this part, we reduced the weight by about 30%, and we cut the number of fasteners in the design that it takes to assemble it by more than half. So we're able to take that technology, apply it to the design, and then also start preparing for printing. And as I mentioned, printing materials are very expensive today, so you don't want to fill your printer with your expensive powder only to find out that the print has failed or that it is warped. And so by being able to prepare the models and then go through the manufacturing simulation, and also to compensate for the design as you go through that simulation, that integrated solution has been a tremendous help to Boeing. And I think step 7, where we will be able to distribute this, one day we envision maybe a airline with a printer and they need a spare part, they swipe their credit card and they print out the part. That future is possible today. I think we just have a little bit more work to do from a certification standpoint. But through the software system, we'll be able to do that. This chart displays the experience that our team has had. The current process is what was used to design this part. It requires a lot of import and export of files to different software packages. This is kind of an industry standard today of different software packages used for topology optimization, for finite element modeling, and for the build package requirements to design support structure and other things. And each of those translations are prone to errors and prone to translation differences. And what we found with the 3D Experience platform is that this has been integrated. And that tool now has combined all of these different functionalities into a single package with a native CATIA geometry, and we're able to translate those models into the finite element system, into the build files and the analysis of the build files to compensate for the models. All of this activity that we were seeing taking weeks to months in some of the original designs, the teams are now being able to do in days what was taking us weeks in the past. So we're seeing a huge benefit from the software and the ability to do that. And we've now got several dozen of our engineers trained in this package and applying it to our new designs. So I'll end with this slide. And it's really about what do we think will happen in the future? Where are we going to go? The slide there on the right is a 3D printed inkjet panel for a ceiling of a commercial aircraft. And it is customized to an airline using inkjet technology and 3D printing capabilities. And so it's just a glimpse into where we might be able to go in the future and integrating different solutions for our customers to provide new customization, new lighter, and integrated structures that we can't do today. But I think the biggest value of additive manufacturing is going to come from the engineers using the tools that they have available to them to design something that just cannot be produced today. It's parts that will not be made with a traditional manufacturing method. These are the kind of parts that we will design in the future that will truly transform aerospace and engineering. And so I'm going to leave you with the question from the video, which is, what will we dream next? Thank you.